Hi everyone, welcome to another interview here in PyCon Colombia. I have the pleasure and I'm really honored to be the interviewer of Robert. So welcome Rob, thank you for being here.
Thank you so much for having me. It's been an amazing conference.
I'm really happy to hear that. And this interview is right after his keynote, and it was a great keynote. So if you can go and watch that in our YouTube channel, welcome. You will enjoy it a lot. And well, let's start. So you have been using Python since 2001. And well, after you see the keynote, you will see that he used Python in other places that maybe you didn't imagine before. So how was that? Like how you start using, like initially using Python for that specific area, right? Like art conservation.
Well, yeah, my first use of Python was when I was working on my PhD, which was completely different. It was simulating fluid flow, and I was using Python to make the plots for my dissertation.
Okay.
But then this made me realize, oh wow, there's really a lot of applications. And then of course, it wasn't long until NumPy came out, and then the whole SciPy blossomed and everything. And I found it to be such a nice community, but also such a nice set of packages that were growing so fast that I more or less never looked back, because I did my PhD writing template metaprogramming in C++.
Okay.
But then after that, I've been using Python pretty much ever since.
Well, you fall in love with, as many of us, with Python and that easiness.
That's right, yeah. And there's always a library for that, no matter what. And the things that I needed to do in working in cultural heritage are the kinds of things that Python is really good at. So processing images, doing optimization problems, managing color, managing a lot of data. Used to be a lot harder than it is now, but I was working on much smaller data sets before. So as my work has grown, the capabilities of Python have also grown along. So it's been a really nice trip.
That's nice. So since it's getting easier now, like because we have more libraries and like many things are happening, what do you think are the challenges that are coming?
Well, I think that the size of the ecosystem is a strength and a weakness, because there are so many packages that have to work together. I've been really impressed lately with UV as a package manager. That's made package management a lot easier. And I think that the advent of large language models for coding means that, on the plus side, a lot more people are writing code. And of course, these models usually default to Python. If you say, write me a program to do X, it will write you a Python program to do X. But it also means that the code quality will go down. So I think that's a big challenge too. We still need experts who really know what they're doing. So
we need to still study and go to the concepts.
For
and
sure.
get them wrong, like correct. And I'm with you. Thank you for that. So to give a little bit more of a glance of what you are doing and then your experience, can you tell us a little bit more of your current job?
I wear a lot of hats. I'm a professor at the University of Amsterdam, split between physics and conservation and restoration. The teaching that I do is totally unrelated to the things I talked about in my keynote. I teach about metallurgy and mechanical properties and corrosion. I do talk a little bit about imaging, science, and human color perception. The research that I do as a professor is, currently I have a PhD student who's about to finish, and she's made a robot that is able to do focus stacking. So it takes a grid of photos of an artwork that may not be flat. For example, a mummy portrait, something that they would put around mummies, and they would paint the face of the mummy and then insert it into the bandages. And so when a museum has a mummy portrait, it's not flat, it's barrel shaped. And this means that it's a real challenge to take a photo, because if you just point a camera at it, the mummy portrait has a curve, and so you have to take many, many, many photos going down and then stacking those. So there's a lot of that kind of work. the work that I talked about in the keynote, which is the main thing, was taking this huge image of the Night Watch. It's nice when you can work at a museum that has a huge budget like this, but most of the museums in the world are not so lucky. So I'm also trying to convert what I learned doing that into projects that smaller museums can afford. So for example, I talked about using this IKEA robot for the turntable. The PhD student is basically trying to make the whole system so it costs less than $2,000. And so this desire to have a bigger impact by democratizing the technology, making sure everything is open source, but also open source hardware. That's another, key thing. Is part of my thrust. Then I am also working at the Museum of Decorative Arts, trying to help, mostly internally, but also with a little bit of stuff that faces the public, trying to help the museum solve their day-to-day tasks using artificial intelligence. So there's a whole lot that goes on behind a museum. If you have a huge collection like the Museum of Decorative Arts does, it's a museum of fashion and toys and advertisement and design and graphic arts. Pretty much anything that any person has ever designed is fair game for the Museum of Decorative Arts. Then managing this collection, finding the object that you're looking for, digitizing things and ensuring the quality is good, entering the things that are in your collection after you photograph them into the database of the museum to say, this is the artist, this is when it was made, this is the provenance, like who owned it before, how did we get it. That's a huge amount of work where I think that artificial intelligence in the form of large language models will be able to help. So I'm doing a lot of work on that front these days too.
So we can expect more amazing projects in the future months.
Amazing is in the eye of the beholder, but
that is my next question.
I'm having a lot of fun, I can say that.
That is my next question, because there is a really amazing project that you shared with me and that I was also checking on the website. That is the Bosch Research and Conservation Project.
Yes.
So can you share with us what you did there, how it started, how it happened, how it was okay, this is the time and this is gonna happen and this is gonna be real and exist.
Yeah, so there's a very famous painter, Hieronymus Bosch, who famously made a painting that in English we call the Garden of Earthly Delights, and it's in the Prado.
In Madrid.
Yeah. But Bosch painted a lot of paintings, not hundreds, but a few dozen. And he died in 1516. So the idea was 500 years after his death, it would be nice to be able to present all of his work with very thorough research and an exhibition, and that would be 2016. So in 2011, I was invited to participate with a group of researchers. We had 2 art historians, an art conservator, a photographer, a technical art historian, and then I was added as the 6th person because I already had a reputation for doing processing of big images. And we basically went to every Bosch painting in the world that would let us in. We brought our own very specialized camera equipment, and we made standardized photography across the whole of Bosch. So the same resolution, same lighting, very, very high resolution. And this meant that we collected something like 20 terabytes of data. And so my role was to find technologies to help bring all of the data together. Because not only did we just take the photos, we took images at different wavelengths. So for example, with an infrared camera, which is a lower resolution, infrared light penetrates through the paint. And so you can see what Bosch may have used when he was planning the painting, or other paintings that he made that he covered up and so on. So I had a huge collection of images in one wavelength, like infrared. I have a huge collection of images in visible. I had to bring them all together, stitch them, get them to be aligned with no evidence that there were seams. And then I had to develop, because our team was spread out,
Everywhere.
I had to develop a viewer technology that would allow people to make this kind of comparison, to zoom in, and to share links between each other, so that if one researcher had a very tight view with an interesting combination of wavelengths, they could just make a URL, send it to their colleague, and get the same thing. So yeah, I worked for 5 years on that project, and the result is a website that I had to teach myself web design to do this, because it was the first website I ever made. It's called boschproject.org, and you can see the results of all of our research there. So.
Amazing. So that is the first project where you use the curtain viewer.
That's right. I invented the curtain viewer for that project. Yeah.
That now you use also in the night watch.
Yeah. Although it's not a Python thing per se, in cultural heritage, you have a really recurring need to make comparisons between images, whether it's before a restoration and after a restoration, or light coming from the left, light coming from the right, X-ray and visible, two interpretations of the same motif by different artists. The need to compare images is consistent. And so I thought, oh, we really need a technology that helps us do this, and nothing existed at the time, so I built one.
That's great. So regarding that, can you tell our community why it's important to integrate with other technologies? You know, like we were talking here about Python, right? But we have other talks, keynotes that are speaking like, okay, we need maybe to learn a little bit of website development, JavaScript,
sure,
and other tools, like maybe what they can do.
Yeah, for me, this is what makes Python such an amazing place to do work, is that, let's say, in contrast to R, which is very good at one thing, and I think R is great, if you wanted to write a web server in R, it's not possible, or at least I wouldn't know how to begin that. So with Python, the ability to have all of these pieces that are working together, I feel like it multiplies, it magnifies exponentially the power of the language. So it's very often the case that I have some results that I've computed. But I want this to be accessible, so I need a web server. Well, fast API, 10 minutes later, I've got a working web server. Right. To do hard things is possible. To do easy things is trivial, right? So it's this kind of idea of having very many very specialized libraries that each do one thing really well, and the confidence that no matter what I need, I can just reach for it off the shelf. The advice that I would give, to answer your question directly, is always spend some extra time researching what has been done. Because there are many times when I found that I would, well, there's no way that someone wrote a Python library to do that. I'll just write my own. Only later to find out that someone had already done it and done it much better than I could ever do it. So the extra time spent researching just what is out there is often really rewarded. And then, of course, I have also benefited a lot by reading the source code of libraries that I admire to learn how do they do it, right? Because we talk about open source, and mostly people admire that because they can just use it for free. But open source means you can open up and look under the hood and see exactly how they did everything. Mm-hmm. And so I think that's incredible as a tool for learning. If you think, oh wow, the way Pandas makes its data frames look in a Jupyter notebook, that's incredible. How did they do that? Oh, well, you can just look at the source code, and now you know.
That's true. And even that could be also another advice, like as a first step to contribute. Even like you are reading it, you are understanding, and maybe you see something that nobody else saw before. Yeah. You can send a PR, or you can help with the bugs.
Documentation is something that can always be improved. There's something that's not clear or whatever, then sending a PR for a documentation fix it's already helpful, right? Yeah. Every little bit counts.
It means a lot. Yeah, everything counts.
Or even just submitting a well-documented bug report is useful, even if you don't know how to fix it. Still, the fact that someone can reproduce it, well, now it exists, now we can track it, other people can see what's wrong, and everyone is happier when we fix a bug, right?
Yeah, that's true, that's true. Well, talking about like returning, well, actually not returning, coming to the present, right? Like you were working in the night watch, and that is a massive piece.
Yes.
Right? Like, can you give us a little, like, those technical details, like how many images were and the size, and
yeah.
how you connect with to the...
Sure, so the painting, first some painting statistics. It's 4.5 meters wide, 3.8 meters tall, 330 some kilograms. It is Rembrandt's largest painting, and I think it's most famous. The whole night, the night watch is the centerpiece of the Rijksmuseum. The building was actually designed for the painting.
For the painting.
So the stats for the photography, I have 8,439 photos, and that comes from 97 rows and 87 columns. I don't have that backwards because the images are wider than they are tall, so there's more rows than columns. Each photo was 100 megapixels, which is something like 11,600 by 8,700 pixels for one photo. And we're close enough that the sampling resolution, which is, that's how we measure the how close up an image is, means that if you're at 1 pixel and you move to the next, each pixel corresponds to a point on the painting. So if you move by 1 pixel, how far do you move on the painting? That is 5 micrometers. So
that is half millimeter.
No, that is,
less.
there are 200 of those in 1 millimeter.
1 millimeter,
because there's 1,000 micrometers
How
in
did
one.
you manage the resolution in the hardware that you use?
Yeah, well, the problem is that when you want to get that close to a painting, to anything, to photograph it in a way that the whole picture is sharp, you can't have the wrong distance at all, you can't have the wrong angle at all. And so that means you have to have a robot. And the robot has to be able to control the camera up, down, left, right, front, back, tilting like this and like this. The only thing we don't worry about is rotations of the camera along its axis, because we can always correct that in software without losing anything. Yeah, so it's a robot that we put the camera on, and it also has sensors that let us see where the painting is.
It was a beautiful dancing between hardware and software. Because
yeah, that's
like both of them had like a really
yeah,
piece
it's
of
a
work.
real ballet, because we the thing about taking 8,439 photos is that if you add 10 seconds to each photo, you just added 90,000 seconds to your total capture time, and that adds up, right? Because an hour is 3,600 seconds. So it has to be efficient, and that means that after you've taken a photo and determined that you can move on to the next location with all of your quality checks, that you already want to get the camera, the motors running, so that when you get there, the camera is already at the close
position.
to the right angle. Yeah, so I really enjoyed this challenge of getting everything to work together and then orchestrating it all with Python and seeing the real-time status.
Yeah, you were an
so
orchestra director.
Yeah, it was a lot of fun.
Mm-hmm.
Once it worked, it was a lot of fun.
Yeah. So you also help, and you are doing, you did something that was a scrap, right? So for some museums about their artworks, and some of them are the Metropolitan Museum, the MoMA, the Rijksmuseum, and the British Library, right? So how was that plan, and did you use Python in that?
It was entirely Python-based. So the idea is that there are certain museums now, it's a trend that's getting more and more common, and I'm really happy about that a museum will release its collection of images of its artworks for free to the public. You know, it used to be that you had to pay for every single one, or they weren't online at all. But the reason I originally wanted to go work at the Rijksmuseum was that they were the first museum in the world to make their entire collection of images free for any use, even commercial use, at the full resolution. So subsequently, the Museum of Modern Art, the Metropolitan, many museums have done this. The challenge is that when a museum puts its artworks online, they have their own metadata. So one museum will give you the artist's name with first name last.
Yeah. The structure of the
Others
data.
will call it the creator instead of the artist, and so on. So the metadata for these images don't match. So I wrote a scraper, basically, in Python using Beautiful Soup, it's the library, that would go and spider all of these websites. Some of them have an API, like the Rijksmuseum has an API, so you don't need to crawl the website, but others, no. Just gathered the images, but I did not gather the metadata except where did the image come from. So I have a big database of images with a URL. Where did I get it? And then Python was used for the second half to use embedding models. One is CLIP, one is Dino V2, and so on, where essentially each image is processed by a neural network and given an address, a high-dimensional coordinate, basically, 1,536 dimensions or 768 dimensions for each image. And the property of this is that when two images are similar, they're next to each other. And this then means that you can make a search engine. So you can come with a new image and see which other images are similar to it or nearby to it in the space.
You are indexing them.
And then you'll be able to show the user images that have a similar content, for example. Yeah.
That's right.
So it's something that I did just as it would be cool if I did this. It would be fun. And so it wasn't a project in which I was working with a museum. It was just like, this should exist. And this would be a fun way to learn some new Python.
I think you are closing that gap or bridge. Yeah, you are creating like a bridge in that gap where the arts feel so far away from the technology. And you are like, no, this is a tool that you can use.
Yeah.
This is another one. And all of that, like humanities and arts people are going to be more close to this, and I think like we are waiting for them in this community. We have been always asking like how we can get more like interdisciplinary, diverse perspective eyes.
Yeah.
So thank you for that.
Well, it's been a real pleasure. I think that this is something that for me was a real revelation, because I used to think that what happened in a museum was boring. I thought a museum is where art went to die. But there are so many interesting technical challenges, and I find it very important to help the world. As I said, my mission is to help the world access, preserve, and understand its cultural heritage. So I think there are a million ways that we in the technical sector can help with this kind of mission. So, yeah.
Great. Thank you, Rob.
Thanks.
So for closing, let's go and see the future, or like imagine the future. So what is your sense? What do you think is going to happen with this new era and your exploration with LLMs and like this kind of revolution, second revolution? It's really fast.
Sure. I think that there are positive and negative aspects to what's happening lately. I mean, the ability of a large language model with the vision capabilities, generative AI, and so on, to make imitation artworks is for me it's not a good development. I think the fact that you can say, turn this into Studio Ghibli, and it will do that, and it does a very good job of it, I don't think that that's necessarily making the world a better place. But I can expect...
Because even a lot of water.
Yeah.
Even they put like a delay of like, you cannot create more than one image per 7 seconds,
Sure.
7 minutes or something like that.
So I think that that's only going to get better. And I hope that people will not be fooled into thinking that something that came from a machine
Hopefully not.
is the same as something that came from a person, in the sense that when a person creates something, it has meaning. There's a soul behind it. There's a life lived with special and unique experiences, whereas an AI is just doing matrix multiplications. So on the good side, I think that cultural heritage is especially interesting and meaningful when it's connected to other things. When I can see, oh, this was inspired by that. We were walking today and we saw this graffiti, and without the story that told me what these things meant, it would have been much less meaningful for me. So I think that AI holds incredible power to help us look into something, to understand how it was made, and to document and connect how the artist made it, and to understand its physical state so that we can ensure that it stays preserved in the future. So that's on the physical sense. But also to put it into a much larger context so that the art has meaning because of how we understand it and because we can bring other people's understanding to our awareness. So I really hope that it will play a huge role in helping us to access, preserve, and understand our cultural heritage.
Thank you so much, Rob. Thank you for your time. So thank you for joining us in this conference too.
It's been a delight, really. I would come back in a heartbeat.
Thank you so much, and thank you, community, for watching us today.